All right, so this is a little preparation. I'm doing this assuming we don't get to it before you guys head to camp. It's about graphing inequalities. I would like you to practice. The truth is, you're going to have to do some of this in chapter 3. These should go pretty quickly, so I would encourage you to do the following numbers. The first thing is just to say, look, when we graph an inequality, there's usually a solution region, and we want to know if these points, for example, are in the solution region. Well, these are just xy pairs, so I want to see if 2 times 0 plus 3 times negative 1 is less than or equal to negative 3. Well, 0 minus 3 is negative 3. Is that less than or equal to negative 3? Yes. So that's a solution. Now I want to see if 2 times negative 3 plus 3 times 2 is less than or equal to negative 3. Well, negative 6 plus 6 is 0. And is that less than or equal to negative 3? No. So this is, not a solution. All right, a little bit of review about how to graph inequalities. X is greater than 2. Well, I want to think about x equals 2 to graph that boundary. And remember, it's a little not intuitive in that x equals something is a vertical line because x is always the same number. It doesn't matter what y is. So I always like to read this as x is always 2. Since it can't be equal to, it can only be values greater than 2. I dash it. It's a dashed line because it's greater than, can't be equal to. And then I shade to the right what x values are greater than 2. Well, 2.0000001, yada yada, and then 3, 4, everything above that. But you only have to take one tiny little step away from 2 to be greater than 2. What about y is less than 3? Well, again, I want to think about the line y equals 3 to graph that boundary. And just like an x line is vertical, a y line is horizontal. And again, I'm going to dash it because it can't be equal to, it has to be less than. And think about that idea that y is always 3. And in this case, less than, so it's all the values below that. All right, what about this? Y is greater than or equal to 1/2 x plus 2. Well, in order to graph that boundary, y equals 1/2 x plus 2, it's a line, so I only need 2 points. If x is 0, y is 2. And if x is 2, half of 2 is 1, 1 plus 2 is 3. So 0, 2, and 2, 3. There's that slope. Up 1 over 2, and it's going to be solid. I want to put another point just to get a good line. It's going to be solid because it can be equal to, greater than or equal to. Now you can kind of suspect that greater than would be above, but one of the things we like to do is test the point 0, 0 and see if it makes it true. Is 0 greater than half of 0 plus 2? Is 0 greater than or equal to 2? No. So that's an indication that that's not in the solution region. So I want to shade away from that. 0, 0 is not part of that solution. And then another reminder about how to graph intercepts when I have it in a linear combination or standard form. If I let x be 0, that's gone, and I can readily see that y would have to be 2. If I let y be 0, that's gone, and x would have to be 6. Not exactly nice on 1, 2, 3, 4, 5, 6. Not exactly nice on the limited graph region they give you, but good enough. The process is what's really important. So again, I can be equal to, so it's going to be a solid. I should have written that up here. Solid, because it's greater than or equal to. Again, solid, because it's less than or equal to. And again, if I test 0, 0, is 0 plus 3 times 0 less than or equal to 6? Yes, it is. So I want to shade so that that point is part of my solution region. If your line happens to go through 0, 0, you have to choose another convenient point that might not be part of your solution region. And then I'm going to remind us how to graph absolute values. And for good measure, I'm going to put a little 3 in the front there. And so remember, absolute value is just a v. And normally it would be at 0, 0 with slopes of -1 and +1. This one got shifted to the left. It's opposite of what you'd think. The plus actually shifts it to the left, but this does actually shift it up. So if I'm affecting, the x value thinks that it's 1 greater than it is, so you got to move it back. That's why the left 1 is. And then if I take every output and add 2 to it, of course that's going to shift it up. So I'm going to go to the left 1 and up 2, and that's where my new vertex is going to, oops, that was to the right, wasn't it? To the left 1 and up 2, left 1 and up 2, that's where my new vertex is going to be. And it has a slope of 3, so 1 over, 3 up. 1 over, 3 up. If this had a negative in front of it, my v would be upside down, just like over here. So there's my absolute value graph. And then again, nicely I can check 0, 0. Y is greater than or equal to 3 times the absolute value of 0 plus 1 times 2. Oops, what was my y? 0. 0, I have suspicion that this is not going to be correct. True, right? 3 times the absolute value of 1. That is not going to work. So I don't want to shade 0, 0, so I must be inside the v. So I think that does it for those. Again, you saw how quickly I did them. You can probably snap those off just as quickly. So give them a go before you get started on Chapter 3.